This is an experiment on plate mechanics. Now, if we consider that plate fixation is actually a composite beam system because we attach the plate to the bone, we can consider different stiffnesses. I would like for you just to test the different stiffnesses that we have here, beginning with the stiffness of the bone, then the plate, then the bone plus the plate, and then the composite plate plus bone plus screws. Which one is the stiffest?
This one.
Why do you think it is the stiffest?
Because of the screws.
Right. Now, take this into your hand and move it again and see what you can feel. Do you feel the shear between the plate and the bone?
Yeah.
There is shear.
Yeah.
And when we apply screws, we are actually counteracting the shear, and this increases the stiffness because now we have a composite beam system. Now let's look at this small experiment here. Now again, we have a number of beams that are very elastic, as you can see. And when we push these beams or give them a bending load, we see that there is a shear between each and every beam. Okay? We can see this by seeing the difference in the heights of these little markings here. There is no stability among the beams. Now, if I lock these beams with this little locking bolt, now I put a bending load on this composite. You see what happens. I cannot bend this into an arch. This actually goes into an S form. This is a very, very stable form because, you see, I have more or less reduced the shear to a point where we have a high stability here just by putting in one little locking bolt. Let's turn to this little experiment. Here again, you see a plate fixation on a generic bone. Each of these two models represents a transverse fracture. We will define that the top of this construction is the tension side. Now, let us try bending from the tension side. What happens? We can feel that there is compression on the transverse fracture. If you place the plate on the compression side of the bone, and now you put a bending load from here, what happens with the gap? The gap actually opens. So this is an unstable situation. Would you like to try this? So the gap does not close if the plate is on the compression side. Now these two objects represent a fracture which has a large gap or a multi-fragmented type of fracture. Now if we place the plate on the tension side as opposed to the compression side, we can now put a bending moment on it. And why don't you try this? Put a bending moment on both and see if there's a big difference. There's not much difference, is there? We have comminution in the diaphysis here, and it really doesn't matter where you put the plate. But as the bone heals, you want the plate on the tension side. Now, please try the models yourself. So now let us discuss the results of this exercise and what you can learn.
In the online faculty support packages, you can find faculty guides for each station and, where appropriate, topics for discussion and frequently asked questions. In case of questions, please send an email to templates@aotrauma.org.